let's take a look again at something that kind of is set up like that last question that you had on the previous page. So back here at the very bottom of that previous page, we had something that looked like this. And we had to make sure that that was the same as our standard form. So I'm seeing a parentheses in the middle with two terms, a binomial, and then it's squared. And when I look at this next page, I see that. I see a binomial squared. That's this part, and then I see a little number on the end. I'm also noticing that there's a 3 there as well, so let's see what happens. It says, verify that these can both be written as quadratics. I'm going to do what I just did. It does remind me to do the order of operations first. So you cannot distribute that 3 in until you've rewritten this. Uh-oh, it's not 3 minus 2. It's x minus 2, you silly dog. X minus 2, x minus 2. Because that's x minus 2 squared, and then minus 5. I'm just going to take care of this first one here. FOIL. X squared, first outer. Okay, now if I multiply x times negative 2 and negative 2 times x, both of those are negative 2x's, so if I combine those, I'm going to get negative 4x. I know that I'm going insanely fast right now. That's just because I'm trying to keep these online videos shorter. So if you need to rewind and watch these a couple times, or better yet, jump on my Zoom classes and we can, get all your questions answered. Obviously, it's not our favorite to do remote learning, but we're doing it, everybody. I'm proud of you. And it is looking like that can be written as a quadratic. Yay. And I'll do this next one also. Yeah, f of x, doesn't matter, you can write it as y. Who cares, either way. So take a second, rewrite these out, and they should look like a quadratic. And you can do them on your own, pause, come back. I'm just going to write the full answer on this one right now instead of going through the whole thing. All right. Now that we have our standard form for these two, so this guy's standard form is here, this guy's standard form is there. We have to use the vertex formula on each of these to find what the vertex is. If I do my first one, I'll do the first one in red. Okay, so if I'm trying to find the vertex of this guy, I have to do negative b over 2a. And my b value is negative 12, and my a value is 3. So x equals negative b value over 2 times my a value, which is positive 12 divided by 6 is 2. When I plug 2 into standard form, I get 3 times 2 squared and then if I work this out, 2 squared is 4, so I have 12 minus 24 plus 7 is negative 5. So using my vertex formula, I found that the vertex for this first one was 2, negative 5. I'll do that same thing on my next problem. I'll do that one in blue. So if I'm trying to find the vertex of this guy, my a value is negative 2 and my b value is negative 16. Okay. X equals negative b over 2a. 16 divided by a -4 is -4. If I plug -4 in to my standard form, I get my f of x equals -2 times and when I simplify that all out, I get a 3. So my vertex for this guy ends up being, well, my x value was -4, my y value is a +3. What do we notice? What's the link between the original form and the vertex for this guy? And what's the link between this original form and this vertex? What you should notice is that the x value of your vertex shows up right here and right here. And the y value of your vertex is right here and right here. So once again, this is the x value of your vertex. And then that last one, that's always your y value of your vertex. That is called vertex form. So when something is written in that form, that's called vertex form. In this math book, they do call it graphing form. That's not as mathy, common, professional, but hey, it's what they say. So if you rewrite this last one as, well, not the last one, second to last one, if you rewrite this, they can be rewritten and you can show that they're the same thing. So go ahead and try that and then jump on to the next video.